I'm Jim Bell. I'm a professor in the School of Earth and Space Exploration, and I'm also the director of the New Space Initiative here at ASU. I want to tell you all a story. I want to tell you a story about a brand new high-tech industry that's being led by rich and famous entrepreneurs who are building and testing amazing new machines that can transport people and cargo far away and rapidly and affordably. And that industry is at the frontier of technology and engineering, and it's pushing those frontiers to their limits, making inventions and innovations that can change the world as we know it. Now, what if I were to tell you that this story happened in 1925, and that this new industry was based on this strange concept called commercial aviation, and that the luxury world of flyboys and flygirls and the super rich would soon become part of the everyday 21st century world, to the point where today we regard air travel as relatively routine. Well, it all started with something called the Airmail Act of 1925, when the US government started giving these juicy contracts to startup companies like American and United to deliver the mail. And they used those contracts to increase their safety levels, to increase their efficiency, to lower costs. And that led to the airline industry of today. Well, this is actually a model for something similar that's happening right now, but in the space business. New small businesses are forming in rocketry, small satellites, space tourism, even mining. And NASA and other space agencies are offering juicy government contracts to startups with names like SpaceX and Virgin Galactic and Bigelow Aerospace. Not to deliver the mail, but to deliver cargo and supplies and eventually people to low Earth orbit. So this is a model that we've seen before in the airline industry. It's a model that we've seen before even in the railroad industry before that. So will this lead to space line travel becoming as routine as airline travel is today? I mean, is it absolutely crazy for me to imagine to be able to spend the weekend on the moon before I retire? Well, when I was growing up, I got turned on by guys driving cars on the moon. I mean, what's up with that? How cool is that? They were driving cars on the moon. I had no idea why they were there. I didn't know anything about the Cold War. I didn't know anything about the geopolitics of space. All I knew is that it was awesome. It was inspirational, and that I wanted to do that. But I had to learn that there are many reasons why we explore space besides, hey, that's really cool. So certainly the inspiration and the value of science and technology and engineering, math education, incredibly important reasons, as is national pride, as is a greater appreciation of our country abroad, because you and we and all of us, we're actually investors in space exploration, assuming you've paid your taxes. We also explore space to learn more about our planet, our solar system, and beyond, so that, for example, we could save ourselves from a potential cosmic catastrophe, like the giant impact that killed the ancient dinosaurs 65 million years ago. I've argued that exploring space is not just a luxury that we can opt to do. We have to learn how to get out into space, to get off this planet, because it's essential to the survival of our species. Well, exploring space also leads to tangible benefits in technology and infrastructure, things like GPS, things like cell phones, weather satellites, new materials for harsh environments, new guidance systems for spacecraft, airplanes, even cars. And there are other examples in foods, medicines, physiology, and the healing of diseases. The space program really is part of our lives. It's more than just tang, but it's not quite yet growing potatoes on Mars. So as we expand farther out, I think it's reasonable to expect that those benefits will expand farther out too. Just like the airlines changed the 20th century, space and space lines are going to change the 21st. Space is the next economic frontier. And low Earth orbit, the space closest to home, already is an important part of our global economy. This is where the shuttle went. This is where the Hubble Space Telescope is. It's where the International Space Station is. It's where the more than 500 astronauts that have flown have gone. But Most people don't realize where low Earth orbit is and how close to home it really is. So I have a little demo to show you. First, I'll grab my prop number 1 and then ask for prop number 2. Thank you. We're going to pretend that this basketball is the Earth. Okay? Where is low Earth orbit? Take a dime and hold it up against the Earth. And that's it. Top of the dime, right there. That's where the shuttle went. That's where the space station is. That's where the Hubble Space Telescope is, just at the top of that dime. Let me give my prop back. Thank you. NASA has been criticized for canceling the space shuttle because it was the nation's only way to get humans into space. Now, I was a huge fan of the space shuttle. I watched it launch, watched it land. I was, incredibly proud of what they were achieving and realizing, of course, the risks that they were taking. But I was sort of glad to see the shuttle retired and to see NASA start to hand over low Earth orbit, that close to home part of space, to corporations, to others, because it's no longer the exploration frontier. It's a different kind of place, very ripe for economic development. In fact, the economic sphere of our planet now extends out into space, at least to low Earth orbit. So I'm happy to see these Earth-based companies get involved in space-based businesses. I want NASA to be pushing the frontiers, to go off to new distant destinations like the moon, which on that scale would be across the room, or Mars, which would be down the street. Those deep space destinations are where new opportunities await, new discoveries, new technologies, new industries that will push our economic sphere even deeper into space. We should expect disruptive new technologies like the transistor and the internet that came before that will change our world and our species. And we've actually begun to explore those deep space destinations already with robots, flyby probes and orbiters and landers and rovers with names like Viking and Voyager and Cassini and Curiosity. And our first looks at those worlds around us are using these robots, doing the things that the robots can do, like determining the size of something or its mass or its topography or the basics of its geology and chemistry, looking at planets and moons and asteroids and comets. And here at ASU, we've been a really important part of that robotic exploration since it began in the 1960s. Faculty, staff, students working on designing, testing, building, operating dozens of space missions in the past, and that continues today. Right now on campus, the Lunar Reconnaissance Orbiter team is taking pictures of the moon at high resolution. The Opportunity and Curiosity rover teams are analyzing data coming back from Mars every day. The Cassini mission exploring Saturn, the Dawn mission exploring the asteroid Ceres. We're building instruments and entire small spacecraft on campus for the future exploration of low Earth orbit, the moon, and beyond. It's a really incredible time, an incredible era of space exploration, and the textbooks are literally being rewritten as we speak. But it's important to ask, do we have to send people out into space? Can we do it with robots? I don't think we can. I think that the things we can do with robots, we should do with robots. But there's a whole other realm of things, more complex work like the forensic work of field geology, or the large-scale complex work of setting up drill rigs, or the fine-scale work of detailed sampling and analysis. Those are the kinds of skills that require the human brain, human intuition, and human experience. I think when people go back into space, back to the moon, to asteroids, to Mars and beyond, and they will, it will be with robots as our assistants and tools instead of just the robots. Now at ASU, we're starting to use our robotic expertise to team with companies out there to explore. I'm the director of something called the Space Technology and Science, or New Space Initiative, and we connect faculty and staff and students with commercial space companies up and down the supply chain. We've got expertise in science, engineering, robotics, instrumentation, laboratory work, operations, and those companies want to be bringing products and services to the market in low Earth orbit and beyond. We can do this to advance our science and engineering and technical objectives while working with these companies. So, for example, some of my colleagues at ASU are experts in asteroids and meteorites. So we partnered with a small company called Planetary Resources that's actually an asteroid mining company. Right now they're prospecting, and so we're helping them to test their prospecting instruments, that are looking for natural resources that could occur on asteroids. And probably the most economically important commodity resource out there is water, as ice or water-bearing minerals on these asteroids. Of course, we can use it for drinking, we can use it for radiation shielding, we can separate the hydrogen and oxygen, use it for rocket fuel, breathable air. Water is really going to be more valuable than gold in space in the future. And at ASU, we've got astronomers and planetary scientists who know how to look for it and who know how to find it. And so when these companies that we partner with begin their prospecting work in the coming decades, they'll be doing what they need to do to look for those resources, and we'll be doing science as well. It's kind of a great win-win partnership, and it's kind of representative of what we're trying to do at ASU New Space, kind of integrating the academic and the commercial space sectors. So, what can you do to help move this new space revolution forward? 3 things. First of all, you can know that you are already investors in the future of space exploration. If you think it's been a great investment, contact your member of Congress and let them know. That is, advocate for steady funding of NASA and other space-related industries and government agencies. You can join organizations like the Planetary Society, which helps do that kind of advocacy as well. Full disclosure, I'm the president of the Planetary Society, so I'm a big fan, and I think it's a great way for like-minded people to get together and help to advocate for space exploration. And finally, you can educate. You can educate yourself and others about your place in space. You might be able to take classes at ASU, for example, in space science, engineering, technology, exploration. Okay? You can educate other people, especially kids. Take them to look through a telescope. Take them to your local astronomy club, astronomy night, and let them see and experience the awe and wonder of the cosmos. Share that awe and wonder that you feel inside yourself with others. So, who could have imagined in the 1920s that by the end of the 20th century, it would be possible to take routine airline flights almost anywhere on the planet? Now we're approaching the 2020s, and I think it's just as hard to imagine that by the end of this century, we'll be able to take routine spaceline flights just about anywhere in the solar system. But that's the future that's coming, and that's the future that many of us across ASU are working to help to create. So that weekend on the moon, it's coming. I know it. And I'm getting ready for it. You should too. Eat well, stay healthy, live long, and prepare to strap on for the ride of your life. Thank you.